Close your eyes for a moment. Imagine the sky just before dawn, still holding the last whispers of darkness, but beginning to glow softly at the edges. The stars are fading one by one, like candles being quietly extinguished. And there, hanging in the pale twilight, is the moon, silver, patient, watching over the world as it has for billions of years. Now, feel the warmth beginning to rise from the horizon. The sun, still hidden, is already sending its light across the curve of the earth, painting the clouds in shades of rose and amber. In this delicate moment between night and day, two ancient forces are at work, not fighting, not competing, but dancing, silently, gracefully, perfectly synchronized. This is the story of how the moon and the sun work together to shape everything you know. The tides that rise and fall, the seasons that turn, the rhythm of your own heartbeat. They are not just distant objects in the sky. They are the conductors of life itself, guiding Earth through the cosmos with invisible hands. For as long as humans have looked up, we have wondered about these two lights. We have built temples to honor them, written myths to explain them, and measured our lives by their movement. But tonight, we're going to go deeper. We're going to explore the hidden partnership between these celestial companions, how they were born, how they work, and why. Without them, Earth would be a very different place to let yourself drift. Let the noise of the world fade away. Because this is a journey that begins not with a bang, but with a breath, a slow, cosmic exhale that has been unfolding for over 4.5 billion years. And it starts, as all great stories do, with creation. In the beginning, there was fire, not the small, flickering kind you see in a hearth, but a roaring, molten inferno, an ocean of liquid rocks spinning through the void of space. This was Earth 4.5 billion years ago, a newborn planet, still hot from its violent formation, orbiting a young star that had only just ignited in the heart of a swirling cloud of gas and dust. The sun was younger then, brighter, perhaps, hungrier. It burned with the ferocity of youth, casting its light across a solar system still thick with debris, asteroids, comets, fragments of worlds that would never fully form. And among this chaos, Earth tumbled through the darkness, alone, but not for long. Somewhere out in the primal solar system, another world was taking shape. Scientists call it Theia, a Mars-sized planet on a collision course with Earth. For millions of years, Theia drifted closer, pulled by the invisible threads of gravity, until one day, the two worlds met. Imagine it, the impact. Not a simple crash, but a cosmic catastrophe so powerful it melted the surface of both planets. Rock vaporized. Oceans of magma splashed into space. The very core of Theia merged with Earth, sinking deep into its molten heart. And from the shattered remains, spinning, glowing, still burning, a ring of debris began to form around our planet. This ring, made of molten rock and metal, slowly cooled, slowly coalesced. And over time, it became something new. Something that would change Earth forever. The moon. It's hard to imagine now, looking up at that calm, silver disk in the night sky, that it was born from violence. But birth is rarely gentle. The moon came into being as Earth's companion, forged in fire, bound by gravity, destined to orbit our world for as long as both exist. In those early days, the moon was much closer, so close that it filled the sky, looming overhead like a second horizon. The tides it created were enormous, rising and falling hundreds of feet, shaping the young planet's surface with relentless force. Days were shorter then, too, just 5 or 6 hours long, because Earth spun faster, still wild with the energy of impact. And the sun? The sun watched it all unfold. Even then, the sun was already doing what it does best, giving, pouring energy into the void, warming the surface of the newborn Earth, driving the first winds, the first storms, the first stirrings of an atmosphere. It didn't know, how could it, that it was lighting the stage for something extraordinary. That one day, on this small, molten rock orbiting in the Goldilocks zone, life would begin. But for now, there was only heat, only motion, only the slow, patient work of gravity pulling things into place. Earth began to cool. The moon drifted outward, settling into a more stable orbit. And together, these two celestial bodies, one burning with nuclear fire, the other cold and silent, began to find their rhythm, a rhythm that would guide not just the planet, but everything on it. Because even in those earliest days, a partnership was forming, a dance between light and shadow, heat and pull, day and night. A dance that continues to this very moment as you lie here listening, breathing in time with the rise and fall of invisible tides. But to understand that dance, we must first understand the dancers. And so, let us turn our gaze toward the sun. Picture the sun not as a distant star, but as a heart that beats once every 11 years. A heart made not of muscle and blood, but of hydrogen and helium, fusing in temperatures so extreme they defy imagination. 15 million degrees at the core. Hot enough to turn matter into pure energy. Hot enough to light up a solar system. And from that heart flows everything. Every breath you take. Every plant that grows. Every gust of wind. Every drop of rain. Every wave that breaks against the shore. All of it. Powered by the sun. It is the engine of Earth's climate. The architect of its seasons. The silent benefactor behind every form of life. But the sun does not give carelessly. It gives in rhythm. Each morning, it rises. Though, of course, it is not the sun that moves, but Earth, turning slowly on its axis, bringing each part of the planet into the light. And with that light comes warmth. The surface heats. Air begins to rise. Winds are born. Oceans stir. And far below, in forests and fields and gardens, chlorophyll wakes up and begins to work, turning sunlight into sugar, into life itself. This is photosynthesis, the quiet miracle that feeds the world. Plants drink in carbon dioxide, bathe in sunlight, and exhale oxygen. And we, in turn, breathe that oxygen, eat those plants, and give back carbon dioxide, completing the cycle. It is a partnership written into the very chemistry of existence. The sun does not know we are here, but we could not be here without it. And yet, the sun is not constant. It flares. It storms. On its surface, massive eruptions of plasma, called solar flares, explode outward, hurling radiation into space. Sometimes, these flares reach Earth, causing auroras to ripple across the polar skies in waves of green and violet. Other times, they interfere with satellites, disrupt communications, remind us that we live at the mercy of a star, but most of the time, the sun is stable, steady, reliable in a way that allows life to flourish. And that reliability comes from its size. The sun is so massive, over 1 million Earths could fit inside it, that its gravity keeps it from collapsing, and its energy keeps it from exploding. It exists in perfect balance, burning hydrogen into helium, holding itself together through forces we are only beginning to understand. This is called hydrostatic equilibrium. The gravity pulling inward is matched by the pressure pushing outward. And for billions of years, that balance is held, but the sun does more than shine. It also shapes. As Earth orbits the sun, tilted on its axis by about 23.5 degrees. Different parts of the planet receive different amounts of light throughout the year. When the northern hemisphere tilts toward the sun, it's summer there. Long days, warm nights, crops growing tall. When it tilts away, winter arrives, short days, cold winds, the world resting beneath snow. This tilt is no accident. Scientists believe the impact that created the moon also gave Earth its tilt, locking in the rhythm of the seasons. And the moon, in turn, stabilizes that tilt, keeping it from wobbling too much. Without the moon, Earth's tilt could shift wildly over thousands of years, causing extreme climate swings that would make life far more difficult, perhaps impossible. Even now, billions of years after their violent beginning, the sun and moon are still working together. One provides the energy, the other provides the stability, and Earth, caught between them, thrives. But there is another rhythm at play here, a slower one, a quieter one. Because while the sun lights the day, it is the moon that governs the night, and the moon has its own story to tell. There is something deeply calming about moonlight. It doesn't burn like the sun. It doesn't demand attention. It simply glows, soft, silvery, reflected light borrowed from the sun and cast gently across the earth. And yet, for all its quietness, the moon holds enormous power, not the power of heat or light, but the power of pull, gravity. The moon may be small, just a quarter the size of Earth, but it is close enough that its gravity reaches across the void and tugs on our planet. It pulls on the oceans, on the land, even on the air itself. And that pull creates the tides. Imagine standing on a beach at dawn. The water is low, exposing rocks and tide pools teeming with life. Hours later, the sea has returned, climbing up the sand, covering what was once dry. This is not random. This is the moon at work, pulling the oceans toward it as Earth rotates beneath. But here's the beautiful part. The sun helps. Too, when the sun, moon, and Earth align during a new moon or full moon, their combined gravitational pull creates what are called spring tides. The highest highs, the lowest lows, the most dramatic rise and fall of water. And when the sun and moon are at right angles to each other, during the quarter moons, their pulls partially cancel out, creating neap tides, which are gentler, less extreme. This is the dance. Not just between sun and moon, but between all three, Earth, sun, and moon, locked in a gravitational ballet that has been choreographed over billions of years. And life has learned to follow this rhythm. In the oceans, creatures time their behavior to the tides. Crabs emerge from their burrows when the water is right. Fish spawn during full moons. Corals release their eggs and sperm all at once, synchronized to lunar cycles, filling the water with clouds of new life. Even on land, animals are affected. Studies have shown that certain birds migrate more actively during full moons. Predators hunt differently depending on how much light the moon provides. Humans, too, have always been tied to the moon, long before clocks, before calendars, before written language. People watched the moon to track time. They noticed that it changed shape, waxing from a thin crescent to a full circle, then waning back again, over the course of about 29.5 days. This became the basis of the lunar calendar, used by civilizations around the world to mark months, plan harvests, and celebrate festivals. The word month itself comes from moon. In many languages, the two are inseparable, and the moon's influence goes deeper still. There is evidence, some controversial, some well-documented, that the moon affects sleep. During full moons, some studies suggest people sleep less deeply, wake more often, and take longer to fall asleep. Whether this is biological or psychological, no one is quite sure. But the idea that the moon reaches into our bedrooms and tugs gently at our rest, that feels ancient, primal. True, because the moon has always been there 4.5 billion years. Every night, rising and setting, pulling the oceans, reflecting the sun, watching over Earth like a silent guardian. And unlike the sun, which blinds us if we look directly at it, the moon invites our gaze. We can stare at it for hours, lose ourselves in its craters and shadows. Wonder who else, across time and distance, has looked up and seen the same light. But the moon is not just a passive observer. It is an active participant in keeping Earth stable, because without the moon, our planet would wobble. And if Earth wobbled too much, the climate would become chaotic, summers unbearably hot, winters impossibly cold, seasons unpredictable. The moon's gravity acts like a stabilizer, holding Earth's tilt steady, ensuring that the seasons remain consistent over millions of years. In a way, the moon is Earth's anchor, and the sun is its engine. Together, they make life possible. But how, exactly, do they work together? What is the mechanism behind this ancient partnership? To answer that, we need to look at the space between them, the invisible forces, the delicate balance, the dance that never stops. Imagine a tightrope walker, balanced perfectly in midair. On one side, the sun, massive, burning, pulling with the force of 400,000 Earths. On the other, the moon, small, cold, but close enough to matter. And in between, Earth, spinning, orbiting, held in place by the tension between these two forces. This is not a metaphor. This is reality. The sun's gravity keeps Earth in orbit, prevents it from drifting off into the cold void of space. But the moon's gravity keeps Earth stable, prevents it from spinning wildly out of control. Together, they create a system so finely tuned that even the smallest change could have catastrophic consequences. Let's start with the orbit. Earth travels around the sun at about 67,000 miles per hour, fast enough to circle the entire star in just over 365 days. This journey is what creates the year, the seasons, the rhythm of planting and harvest. But the orbit is not a perfect circle. It's an ellipse, meaning Earth is sometimes closer to the Sun, sometimes farther away. Right now, Earth is closest to the Sun in early January, during winter in the Northern Hemisphere, and farthest in early July, during summer, which seems backward, doesn't it? But here's the key. Distance from the Sun is not what causes the seasons. Tilt is. Because Earth is tilted, the Northern Hemisphere leans toward the Sun in summer, receiving more direct sunlight, even though Earth as a whole is farther away. In winter, it leans away, receiving less direct light, even though Earth is closer. The same happens in reverse for the Southern Hemisphere. And this tilt, stabilized by the Moon, is what makes the seasons predictable, stable, life-sustaining. Without the Moon, that tilt could shift dramatically over thousands of years. Earth could tip on its side, like Uranus, or wobble chaotically, like Mars. And if that happened, the climate would become unstable. Ice ages could come and go unpredictably. Entire ecosystems could collapse. But the Moon prevents this. How? Through a phenomenon called tidal locking and gravitational torque. The Moon's gravity doesn't just pull on the oceans, it pulls on the entire planet, creating a subtle bulge in Earth's shape. And because Earth is spinning, that bulge doesn't line up perfectly with the Moon. It's slightly ahead, dragged forward by Earth's rotation. This creates friction. And that friction does two things. First, it slows Earth's rotation very, very slowly. Billions of years ago, a day on Earth was only about 6 hours long. Now it's 24. And in the distant future, it will be even longer. Second, it pushes the Moon away, also very slowly. The Moon is currently drifting away from Earth at about 1.5 inches per year. Someday, far in the future, it will be too far away to stabilize Earth's tilt. But that won't happen for billions of years. For now, the Moon remains close enough to do its job, and the Sun? The Sun doesn't just warm the planet. Its gravitational pull also interacts with the Moon's orbit, creating what are called perturbations, tiny wobbles and shifts that, over time, average out into a stable system. In a way, the Sun and Moon keep each other in check. The Sun prevents the Moon from drifting too quickly. The Moon prevents Earth from tipping too far. It's a three-body problem, and it's one of the most elegant solutions in all of nature. But the dance is not just gravitational. It's also visual. Every day, the Sun rises and sets. Every night, the Moon follows, sometimes visible during the day, sometimes hidden, sometimes full and bright, sometimes just a sliver. And twice a month, during the new moon and full moon, the three align in a straight line: Sun, Earth, Moon, or Sun, Moon, Earth. And when that happens, something extraordinary occurs. Eclipses. There is a rhythm to life that most of us never think about. A rhythm older than cities, older than civilization, older than humanity itself. It pulses through the oceans, flows through the forests, beats inside every living thing. And it is set not by clocks or calendars, but by the Sun and the Moon. It begins in the oceans. Billions of years ago, the first life on Earth emerged in shallow tidal pools, places where the sea met the land, where the water came and went with the pull of the Moon. In these pools, organic molecules mixed, combined, and eventually formed something extraordinary: cells, the first living organisms. And from the very beginning, life was shaped by the tides. Imagine a single-celled organism floating in a tidal pool. Twice a day, the water rises and falls. Nutrients wash in. Oxygen levels change. Temperature fluctuates. To survive, that organism must adapt, must learn to respond to the rhythm of the tides, to anticipate the rise and fall, to sync its behavior with the Moon. And so it did, over millions of years. Life evolved internal clocks, circadian rhythms, that mirrored the cycles of day and night, of lunar phases, of seasonal changes. These clocks are not metaphorical. They are real, biological mechanisms, written into the DNA of nearly every living thing in humans. The circadian rhythm is controlled by a tiny cluster of cells in the brain called the suprachiasmatic nucleus. This cluster acts like a master clock, responding to light from the sun and sending signals throughout the body, telling you when to wake, when to eat, when to sleep. Disrupt this rhythm through jet lag, shift work, or artificial light, and the body suffers. Sleep becomes difficult. Mood deteriorates. Health declines, because we are not meant to ignore the sun, but the moon, too, plays a role. Studies have shown that sleep patterns subtly shift with the lunar cycle. People tend to go to bed later and sleep less deeply in the days leading up to a full moon. This effect is more pronounced in communities without artificial light, suggesting that, in our ancestral past, the moon's light influenced when and how we slept. Even now, in our brightly lit, modern world, the moon still reaches us, and it's not just humans. Plants, too, follow these rhythms. Many open their flowers at dawn and close them at dusk, tracking the movement of the sun. Some even orient their leaves to follow sunlight throughout the day, a behavior called heliotropism. And certain plants are more sensitive to lunar cycles, growing faster or flowering more during full moons. In the animal kingdom, the examples are endless. Salmon migrate upriver during full moons, when the tides are strongest. Wolves and coyotes are more active during bright nights, when hunting is easier. Sea turtles, guided by moonlight, return to the beaches where they were born to lay their eggs. And coral reefs, entire ecosystems, synchronize their reproduction to the moon, spawning all at once in a spectacle that turns the ocean milky white. This is not coincidence. This is evolution responding to the steady, reliable rhythm of the sun and moon. But there's something even more fundamental at play here. The very air we breathe is a product of the Sunday photosynthesis, the process by which plants convert sunlight into energy, also produces oxygen as a byproduct. Without the sun, there would be no photosynthesis. Without photosynthesis, there would be no oxygen. Without oxygen, there would be no us. Every breath you take is a gift from the sun, and the water you drink, that, too, is shaped by these forces. The sun drives the water cycle, evaporating water from oceans, lifting it into the atmosphere, where it condenses into clouds and falls as rain. The moon, meanwhile, influences where that rain falls by affecting ocean currents and atmospheric pressure. Together, they ensure that water moves across the planet, nourishing life wherever it goes. Even the soil beneath your feet owes something to the sun and moon. Weathering, the slow breakdown of rock into soil, is driven in part by temperature changes caused by the sun's heat. And tidal forces, created by the moon, help mix nutrients in coastal waters, feeding the plankton that form the base of the ocean's food. It all connects, from the smallest plankton to the largest whale, from the deepest root to the tallest tree, from the first breath of a newborn to the last sigh of the old. Everything is linked to the rhythm of sun and moon, and nowhere is this more clear than in the moments when they align, when day becomes night in the middle of the afternoon, when the moon turns red against a darkened sky. These are the eclipses, the moments when the dance becomes visible to all. There is a silence that falls during a solar eclipse, not just among humans, but among all living things. Birds stop singing, insects grow quiet, the air cools, and the sky, the familiar blue sky, begins to darken, as if dusk is arriving hours too early. This is one of the rarest and most beautiful sights in nature, the sun and moon, perfectly aligned, so that the moon passes directly between Earth and the sun, casting a shadow across the planet from where you stand. The sun, so vast, so blinding, begins to disappear. Slowly at first, a bite taken out of its edge, then more, until only a sliver remains, a bright crescent glowing against the blackness. And then, totality, the sun is gone. The moon covers it completely, and for a few precious minutes, the world is transformed. Stars appear in the middle of the day. The horizon glows with a strange 360-degree sunset, and around the dark disk of the moon, the sun's corona, its outer atmosphere, blazes in tendrils of white and silver, like a halo, like a crown. It is breathtaking, otherworldly, a reminder that we live on a planet moving through space, accompanied by celestial companions that, every so often, align in ways that defy the ordinary. But here's the remarkable thing. This only happens because of a cosmic coincidence. The sun is about 400 times larger than the moon, but it is also about 400 times farther away, which means, from Earth, they appear almost exactly the same size in the sky. And that is why, during a solar eclipse, the moon can cover the sun so perfectly. This is pure chance. There is no reason it has to be this way. On most planets, if they have moons at all, the moons are either too small or too far away to create such perfect eclipses. But here, on Earth, we are fortunate. We get to witness this alignment. We get to see the dance made visible, and it is temporary. Remember, the moon is slowly drifting away. In a few 100 million years, it will be too far from Earth to completely cover the sun. Solar eclipses will still happen, but they will be annular eclipses, where the moon appears smaller than the sun, leaving a ring of light around its edge. The perfect total eclipse, the kind we see now, is a gift of this particular moment in time. But there is another kind of eclipse, equally beautiful, though less dramatic, a lunar eclipse. This happens when Earth passes between the sun and the moon, casting its shadow onto the lunar surface. And because Earth has an atmosphere, the shadow is not completely dark. Instead, sunlight bends around the edges of the planet, filtering through the atmosphere and casting a red glow onto the moon. A blood moon. Ancient people saw this and were afraid. They thought the moon was being consumed, that the world was ending, that the gods were angry. But we know now what is really happening. Light from all the sunrises and sunsets happening on Earth at that moment is being refracted onto the moon. Painting it red.it is, in a sense, the shadow of every sunset and sunrise on Earth, all at once, and it is beautiful. Eclipses remind us that the universe operates on scales we cannot always perceive, that the sun and moon, so distant, so separate, can come together in ways that change the sky, change the light, change the way we see the world. They remind us that we are part of something larger, and they have always reminded humanity of this, long before there were watches, before there were clocks, before there were written calendars. Humans looked up, they watched the sun arc across the sky. They watched the moon grow full and then fade. They noticed the stars shifting with the seasons. And from these observations, they learned to measure time. The sun gave them the day, the moon gave them the month, and the stars gave them the year. This was the beginning of timekeeping. And it was written not on paper, but in stone. At Stonehenge, in England, massive stones were arranged thousands of years ago to align with the solstices, the longest and shortest days of the year, when the sun reaches its highest and lowest points in the sky. On the summer solstice, the sun rises directly over one of the stones, casting light into the center of the monument. This was not decoration. This was a calendar, a way to track the turning of the seasons. In Egypt, the pyramids were aligned with the cardinal directions and the stars. The rising of the star Sirius signaled the annual flooding of the Nile, which brought life to the desert. The Egyptians used the moon to divide the year into months and created one of the first solar calendars, with 365 days. In Central America, the Maya built observatories and developed incredibly accurate calendars based on both the sun and the moon. They could predict eclipses. They tracked the cycles of Venus. They understood that time was not linear, but cyclical, always repeating, always returning. And across the world, cultures celebrated the full moon, harvest moons, hunter's moons, wolf moons. Each full moon had a name, tied to the season, tied to survival. The harvest moon, for example, rises shortly after sunset for several nights in a row, providing extra light for farmers to gather crops. Before electric lights, this was invaluable. The moon was not just a timekeeper. It was a companion. And the sun? The sun was life itself. Solstice festivals, equinox celebrations, the return of light after the long winter. Nearly every culture has a festival honoring the sun, because without it, there is no food, no warmth, no life. Even today, in our modern world, we still live by the sun and moon. We still celebrate the new year at the winter solstice, when the sun begins its return. We still mark Easter by the first full moon after the spring equinox. We still feel the shift in mood as the days grow longer in spring and shorter in fall. We are, whether we realize it or not, still timekeepers of the sky. And as we move into an age of artificial light, of screens and schedules, it is worth remembering that these rhythms, these ancient, celestial rhythms, are still with us. They are woven into our biology, our culture, our very sense of time, and they are fragile. We live in an age of electric light, Cities glow all night long. Streetlights, car headlights, the blue glow of screens. They push back the darkness, keep us awake, let us work and play long after the sun has set. And in many ways, this is a triumph, a sign of progress, but it comes with a cost, because when we flood the night with artificial light, we lose something important. We lose our connection to the rhythm of the moon and the stars. We lose the deep, restful darkness that tells our bodies it is time to sleep. And we lose the awe, the simple, profound awe that comes from looking up at the night sky and seeing the Milky Way. Studies show that exposure to artificial light at night disrupts our circadian rhythms. It suppresses melatonin, the hormone that helps us sleep. It increases the risk of insomnia, depression, even certain cancers. Our bodies, evolved over millions of years to respond to the sun and moon, do not know how to handle this constant, unnatural brightness. And it's not just us. Animals are affected, too. Migrating birds become disoriented by city lights and crash into buildings. Sea turtles, which use moonlight to navigate, are drawn toward artificial lights and end up far from the ocean. Insects swarm around streetlights until they die of exhaustion. The natural rhythms, those ancient, reliable rhythms set by the sun and moon, are being disrupted, but there is hope. Scientists and city planners are beginning to recognize the importance of darkness. Dark sky initiatives are working to reduce light pollution, to design lighting that minimizes harm to wildlife and human health. And more people are becoming aware of the value of reconnecting with natural rhythms, turning off screens before bed, spending time outside, watching the moon. There is also a growing understanding of how solar energy can help us move toward a more sustainable future. The sun, after all, is the ultimate renewable resource. Every hour, it delivers more energy to Earth than humanity uses in an entire year. By harnessing that energy through solar panels, solar farms, and new technologies, we can reduce our dependence on fossil fuels and lessen our impact on the planet. And as we look to the future, we are also rediscovering the moon. Space agencies around the world are planning missions to return humans to the lunar surface. Not just to visit, but to stay, to build habitats, to mine resources, to use the moon as a stepping stone to deeper space exploration. In doing so, we are acknowledging something ancient cultures knew instinctively. The moon is not separate from us. It is part of our story, part of our future, and so is the sun, because ultimately, everything we are, everything we build, everything we hope for, is powered by these two celestial bodies. The sun gives us energy. The moon gives us stability. Together, they make life possible, and together, they will guide us forward. And so we return to where we began, the sky at dawn, the moon fading, the sun rising. You have traveled through time, from the violent birth of the moon to the quiet present, where the sun and moon continue their ancient dance. You have seen how they shape the tides, the seasons, the very rhythm of life. You have watched eclipses, learned about calendars, and understood how deeply connected we are to these distant lights. But most importantly, you have remembered something simple. We are not alone, that we are accompanied, guided, held in place by forces far greater than ourselves. The sun will rise again tomorrow. The moon will follow. The tides will ebb and flow. The seasons will turn. And life, in all its forms, will continue to move in time with them. This is not something to fear. It is something to trust, because for over 4.5 billion years, this dance has never stopped. And for billions more, it will go on. Long after we are gone, the sun will still shine. The moon will still pull. And somewhere, perhaps, new life will look up at the sky and wonder, just as we have, what it means to live beneath two lights. Let yourself rest now. Let the weight of the day fall away. Let the rhythm of your breath slow, matching the rise and fall of the tides. Let your thoughts drift, like clouds moving across the face of the moon. You are part of this story, part of this dance. And as you close your eyes and let sleep come, know that the sun and the moon are still there, still moving, still guiding the earth through the endless dark. Watch over you. They always have that. They always will.